Welcome to the lesson on Pareto chart, construction and analysis. Upon completion of this lesson, learners will be able to define Pareto charts and justify defects to investigate by constructing and analyzing a Pareto chart. Continuous improvement is closely associated with determining the causes of defects or nonconformities in a production process. If a company can determine why they are producing defects, then they have the ability to make improvements and potentially reduce their defect production. However, determining the most important defect cause is critical to the process of suggesting process improvements. A Pareto chart is extremely helpful in determining the most important causes of nonconformities. A Pareto chart is a graphical representation of data collected indicating the causes and their frequency for a particular problem. It provides information on the cause resulting in the most defects or the defects most prevalent in the system. The example Pareto chart you see here displays 6 defect causes in a production process along the x-axis. The vertical orange bars indicate the number of times each defect was detected during 1 week of production. For example, approximately 70 defects resulted due to cause number 1. The purple curved line on the chart indicates the cumulative percentage of the number of problem occurrences. So therefore, cause category 1 is responsible for about 55% of all defects, and category 1 plus category 2 are responsible for 80% of all defects. The cumulative percentage line continues to move up and never moves down because you are always adding in more defects to the cumulative percentage. Pareto charts follow the 80-20 rule, meaning that 80% of all defects seen are attributed to only 20% of the potential causes. This rule implies that the number of defects can be significantly reduced by investigating the 20% of causes that are most prevalent. These causes can be determined by the 80% mark on the cumulative percentage line. So, for this example, 80% of the defects are created by cause 1 and cause 2. These causes would be the ones that you would focus on improving to yield the largest return on investments. Although Pareto charts are effective tools for indicating the causes occurring most often, they cannot take into account defects generated by a combination of factors and causes. Each defect must be put into a single cause category and cannot be classified under multiple factors. Let us look at the essential steps to construct a Pareto chart. You must first collect the numeric data for your problem by recording each time a defect occurs over a set period of time. After the data is collected, tally the number of defects attributed to each cause. Next, the results are charted with each cause category in descending order. Next, calculate the percentage of each of the defects and graph the cumulative percentage line. When the cumulative percentage line reaches 80%, a vertical line is drawn to denote the 80/20ths rule. The causes of the defects to the left are those that should be addressed to reduce the major defects in the system. The example here will walk you through the construction of a Pareto chart. A tire manufacturer has determined that too many errors are occurring at one of its facilities. These errors are especially prevalent in its sports utility tire line. Specifically, 7 types of defects have been observed: cracks, lightness in the sidewall, blister, scuffs or abrasions, slices, bumps, and exposed cords. These defects are significant because they can lead to tread separation and tire blowout, both of which can cause the driver to lose control of the vehicle. Step 1 in the process is data collection. The tire manufacturer samples 10,000 tires, finding that some tires had 1 or more defects while others had none. The table shows the tally of the number of defects found in the tires in descending order. The total number of defects is 982. Next, the percentage of each defect in relation to the total number is calculated. In this example, there are a total of 982 defects, so the percentage of scuff or abrasions is calculated as follows: 359 divided by 982 times 100 equals 36.6%. This percentage is calculated to obtain the cumulative percentage, which is determined by adding the percentages for each defect to the defects before it. The cumulative percentage continues to increase until it equals 100% because it includes all categories of defects. This table shows the percentages calculated for each defect and the cumulative percentage in descending order. With the information resulting from steps 1 and 2, a Pareto chart can be constructed. First, the number of defects is graphed as vertical bars along the x-axis. Then the cumulative percentage is represented as a line graph. Next, we follow the 80-20 rule and look for the causes that make up 80% of the total defects. This chart indicates that 80% of the defects can be attributed to scuffs or abrasions, cracks, and blisters. To improve quality of the tires, the quality team should focus on the causes of these three defects by reducing, controlling, or eliminating them. In summary, a Pareto chart is one of the basic tools of quality control and is a great method to narrow down and justify to upper management the need to investigate a small number of defect causes that are contributing to 80% of all defects. However, a major limitation of Pareto charts is that each defect must be put into a single cause category and cannot be classified under multiple factors. This may be difficult to do in a real-world situation where defects can be caused by a combination of factors. Thank you.